Hello friends, welcome to my video. So we will be discussing the fifth problem of RMO 2023, and the problem is on the board, and today was RMO exam, so I hope people had a good exam today. Let's start. So we are given that n is greater than k is greater than 1 and they are positive integers. So to determine all positive real numbers a1 to an which satisfy this inequality, this equality, root of k into ai to the power k, right? So and there's a summing from I equal to 1 to n, so this term, and the sum of a1 plus a2 plus an is also equal to n. Okay, now I'll say that this is actually equality. It's an inequality which is gifted to the solver as an equality. And the very obvious equality case in this problem, so like if you absorb the problem properly, you're given that summation of ai till n is equal to n, and that summation is basically, like for example, a1 plus a2 plus so on till an equals n, that is given to you. Now it will be very comfortable to put all a's to be 1, right? And if you put it 1 here, then you will get k upon k minus 1 plus 1, which is k upon k, which is 1. So, and you're summing n, the 1 at n times, so that gives n again. So that satisfies as well, and that is also one of the solution. So it's a very comfortable case to work with. And why I'm saying it's an inequality wrapped as an equality is because you'll see it's basically like an inequality which gives this condition, and there's an inequality between this term and this term, which is given as an equality case. Now let's first decode what they mean by this term, right? So the solution is on the board, but I'll try to motivate the solution, because this is problem 5. It's supposed to be tough. It's supposed to be very tough, because the problem 6, as we saw, was a very good problem, but the problem 5, it's actually a very easy question, but we'll try to motivate it. So k minus 1 times ai to the power k plus 1, this thing is a denominator, divide by k. Now the thing is that you can break this into k terms, where k minus 1 terms are the ai to the power k things, and there's one thing, right? And you take the arithmetic mean of them, and as we know by AMGM inequality, this thing will be greater than the geometric mean, and the geometric mean will be nothing but a पर k minus 1, right? क्योंकि if you अगर इसका आप देखोगे तो यहाँ पर ये काफी मतलब मोटिवेट इसलिए भी लग रहा है क्योंकि यहाँ पर k minus 1 and 1 दे रखा है, एंड यहाँ पर k दे रखा है, तो आपको कुछ ना कुछ डिनोमिनेटर चाहिए जो आपका ये वाला k भी कैंसिल कर दे और ai की भी कुछ पावर ले है, तो आपको वैसे सोचना चाहिए. और यहाँ पर हमारा जो ज्योमेट्रिक मीन है वो आपका ai पावर k minus 1 भी बहुत ही ब्यूटीफुली आ रहा है. तो अगर बस इसको k को उधर ले जाएंगे तो फिर हमारा k minus 1 इंटू ai टू पावर k प्लस 1 इज ग्रेटर देन इक्वल्स टू k इंटू ai पावर k minus 1 आ जाएगा बहुत ही ब्यूटीफुली. एंड इसको बस सब्स्टिट्यूट कर देंगे तो हमारा ये आ जाएगा दैट दिस टर्म इज लेस देन और इक्वल्स टू रूट ऑफ k इंटू ai power k upon k into ai to the power k minus 1, right? And I mean, if you simplify this, you'll get root of ai, and now see, now you get root. And the thing with root is that whenever you see root, you always tend to think of RMS inequality, RMS greater than equals to AM. So RMS is nothing but root mean square, AM is arithmetic mean. So the arithmetic mean of root a1, root a2, so on till root an is nothing but root a1 plus root a2 plus, so it's nothing but root a1 plus root a2 plus so on and so on plus root an divided by n. This is the arithmetic mean of roots of these things, right? That is the arithmetic mean that we have now, the new arithmetic mean that we are generating. And the RMS, that is the root mean square. So first you square these roots, and square for root is the number itself. So ai plus a1 plus a2 plus, so it becomes a1 plus a2 plus so on till an, and you take the mean of this and then you take the square root, this will become the root mean square, right, as we know. And this is nothing but, RMS is nothing but equals to 1, because this is given as n, so n by n is nothing but 1, and an is given as this thing, and we just now prove that since this term is less than equals to ai, so the summation of these terms, which is n, is less than equals to summation of ai, which is equals to summation of ai, and this thing equals n. So basically summation of ai is greater than equals to summation of these things, which equals n. So the arithmetic mean here is nothing but this guy on the numerator, ये n से बड़ा है और वो n से डिवाइड हो रहा है, तो फिर ये जो है ये आपका am जो है ये 1 से बड़ा हो जाएगा एंड RMS करस्पॉन्डिंग 1 हो जाएगा. इसका मतलब आपका am जो है वो आपका RMS से बड़ा आ रहा है. बट हमें RMS am इनइक्वालिटी से ये भी पता है कि am जो है वो हमेशा RMS से छोटा आना चाहिए. तो इससे हम लोग ये कह सकते हैं कि am जो है that should be equal to the RMS, and basically equality case should hold. So since equality case is holding here, it means that all a1, a2, a till an, all of them should be equal, and since their sum is equals to n, so they all should be equal to 1, and that also satisfies. And you can also check it here. The reason why we broke it up like this, because am g inequality में भी जब equality case आएगा तब ai to the power k will be equal to 1, which will be equal to all the other ai's to the power k. और फिर उससे भी हमें बेसिकली इक्वालिटी केस से हम लोग ने इस चीज को मोटिवेट किया, हम ऐसे भी सोच सकते हैं. और ये काफी ऑब्वियस भी है, मतलब क्योंकि एआई जो है वो आपका 1 होना चाहिए, और एआई को अगर k-1 टाइम समेशन करोगे तो आपका फिर इक्वालिटी केस में एआई इक्वल टू 1 वर्क भी कर रहा है. सो दिस इज द ओनली पॉसिबल सोल्यूशन विच इज देयर. And that is the solution to this problem. I think this problem was very easy for a 5th question as compared to the last question, and it is like an inequality gifted to the solver as an equality. I mean it's literally a gift to the person, because the equality case is pretty obvious. So like if you like to think what the actual inequality should be. So the condition that they want, like if you want to mold this into an inequality question, what we can do is that we can write it like this. So so in RMO what they usually do is that they give, so a1 plus a2 plus so on till an is equals to n, and summation of this thing, I'm calling this thing as s, so like this thing is s. So they will tell you that s, this thing, you have to prove that this thing is less than or equals to n, right? So so first you'll prove, I mean the method is same, but they usually give it like this. This time they tried a different method. They wanted to gift it to the viewer as an equality, which I think is an interesting way to mold this question and present it to the viewer. So that's the solution to this question. I hope you enjoyed the solution, and thank you for viewing this video. Do share and comment any other questions that you'd like to see the solutions of, or you like to give some other solution for this problem or some other variant for this problem. Then you're welcome, and share it with your friends who have given the exam or who want to aspire to give this exam in future, or who just like math and inequalities. Thank you.